right, so you're ready to move on from Scratch to Python. Well, that's fantastic. Today we're diving deep into a core concept that'll really help make that transition smooth. We're talking about iteration structures, or as us non-coders like to call them, loops. And we've got some notes here comparing how these work in both languages, ready to unpack.
Yeah, and you'll be surprised at how familiar some of these Python structures feel, even with a different syntax.
For sure. Let's kick things off with the repeat until block from Scratch. You know, the one where you're basically telling the program to keep doing something until a certain condition is met?
Yeah, in Python, it's the while loop that takes on this role. But there's a slight twist. It's more about stating, keep doing this while this is true.
So it's like looking at the same idea, but from opposite sides of the coin, like a glass half full versus half empty kind of approach.
Exactly. And our notes even have a Python code example, just to show you how this works in practice.
Okay, let's see.
Python.counter.
Right.
While counter 5. While counter 5. While counter 5, counter, while counter 5, while counter 5, counter my with 3.
Okay, so we start with the counter variable and set it to 0. Then the while loop basically says, as long as this counter is less than 5, keep running the code that's indented underneath.
Right, and those indented lines are doing two things. First, printing out the current value of the counter, and then increasing it by 1. So it's like counting from 0 up to 4.
Which actually, if you think about it, is exactly what you do in Scratch with a repeat until block.
Yeah.
If you wanted something to happen 5 times.
Precisely. But here's where it gets really important in Python. That condition you set in your while loop, it absolutely has to become false at some point. If it doesn't, well...
I'm getting the feeling this is where things could go wrong.
You bet. You end up with an infinite loop, which means your code just runs forever because that condition never changes. Definitely not what we want.
Yeah, no kidding. Okay, mental note, always double check those while loop conditions in Python. Now, switching gears a little bit, let's talk about the repeat block in Scratch. Simple and straightforward, do something a fixed number of times.
Right. Python handles this with its for loop, often paired with the handy range function.
Range sounds intriguing. But first, let's see the Python for loop in action. Think our notes have an example.
They do. Here's the code, .python.func for I in range.print. This is iteration, I.
Okay, so we've got for I in range 10, and then it's printing something about an iteration. What's the I all about?
That I is a variable, and the magic here is that it automatically keeps track of which iteration you're on. So the first time through the loop I would be 0, then 1, then 2, and so on, all the way up to 9.
Oh, that's pretty neat. In Scratch, you'd have to create a separate variable and manually update it to keep track of the loop count. Python just does it for you.
Exactly. Now, about that intriguing range function, what's fascinating is how much control it gives you. It's not just about doing something a fixed number of times like we just saw.
Okay, you've got my attention.
Yeah.
What else can range?
Well, think of range 10 as generating a sequence of numbers, from 0 up to but not including 10. But you can customize this. You can tell range where to start, where to stop, and even the step size between numbers.
Hold on. So it's more than just counting one by one. That's way more flexible than anything in Scratch.
Absolutely. Speaking of flexibility, our notes have an example showcasing how range can be customized.
Okay, let's have a look.
Python 9. For I in range 2, 10, 2. For I in range 2, 10, 2. Print lay.
Let's see, range 2, 10, 2. Okay, so the first 2 is where we start, the 10 is where we stop, but don't actually include, and that last 2 is...
A step size, that's telling range to count up by 2s. So this loop will print out 2, 4, 6, and 8.
That's super useful. In Scratch, we mostly use loops with numbers, but you're telling me Python can loop through other types of data too.
Oh, absolutely. And this is where Python really shines compared to Scratch. You see, in Scratch, you often need separate blocks for different types of data when you're looping.
Okay, so like if I wanted to loop through each letter in a word in Scratch, I'd need a specific block for that, and then a different one for, say, looping through a list of items.
Exactly. But in Python, it's all handled with the same elegant for loop structure. Let's take a look at a couple examples from our notes to illustrate this.
Please do. This is making me rethink everything I thought I knew about loops.
First, here's how you'd loop through each letter in the word Scratch using Python. Python, word, Scratch, for letter in word. For letter in word, print.
All right, so we store the word Scratch in a variable called word. Then the for loop basically says for each letter in the word, do something, which in this case is printing the letter.
That's it. And look at how simple and clean that is. Now let's look at looping through a list of colors. Python.colors are red, blue, green. For color in colors. For color in colors, print color.
Wow, same structure, different data. So Python can just intuitively loop through different types of information without needing specialized blocks or commands.
Exactly. This is one of the reasons Python is so popular. It's powerful, yet often quite readable and intuitive once you get used to it.
I can definitely see that. It's like Python was designed with simplicity and versatility in mind.
And the best part is this versatility extends to even more complex scenarios. Python can handle nested loops where you have a loop inside another loop, and even ways to control the flow of those loops with special keywords like break and continue.
Nested loops, controlling the flow. Now, this is where things start to sound really interesting. It feels like we've just scratched the surface of what Python loops can do.
You're absolutely right, and that's exactly what we'll be diving into in part 2 of our deep dive. So are you ready to explore those nested loops and flow control tools we just mentioned?
Absolutely. Nested loops sound especially intriguing. Is it really just a loop inside another loop?
That's the gist of it. Imagine you want to create something like a multiplication table. You know those grids we all used to memorize back in school?
Okay, I can kind of see where this is going. You'd need one loop to handle the rows and another to handle the columns.
Right. And that inner loop, the one handling the columns, would run completely through for each row the outer loop creates. It's a loop within a loop. Hence the name nested loops.
Okay, that makes sense. It's like those Russian nesting dolls. Each one fits inside the next.
Perfect analogy. And just to give you a taste of how this looks in Python, here's a code snippet that generates a multiplication table.
Okay, break it up.
Python for I in range 1, 11. For j 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 in range 1, 11.
Wow. Okay, there's a lot going on there. We've got two for loops, one nested inside the other. And what's with that NT part?
Great questions. So that first for loop with I is controlling the rows, while the nested for loop with j handles the columns. For each combination of I and j, we calculate their product and print it out. The NT is just a way to separate the numbers with tabs so they form those neat rows and columns we expect in a multiplication table.
So it's like formatting the output to look visually like a table.
Precisely. And this is just one example. Think about games where you have a grid-based map. You could use nested loops to generate the map, check for collisions, even handle AI movements.
My mind is already buzzing with the possibilities.
Yeah.
It feels like nested loops add a whole new dimension of control and complexity to what we can do with Python.
And the best part is you're not limited to just for loops. You can nest while loops, even combine different types within each other. It all depends on the logic you need for your program.
This is way more powerful than anything I ever did with loops in Scratch.
Absolutely. But what if you don't always want a loop to run its full course? Sometimes you might need to jump out early or skip certain iterations.
And now that you mention it, I was wondering about that. Is there a way to interrupt a loop in Python?
There is. Python has two keywords specifically for this: break and continue. They give you a lot more control over how your loops behave.
Okay, break and continue. Tell me more. What do they actually do?
Okay, so think of break as an emergency exit from your loop. No matter what the loop's condition is, if it hits a break statement, it stops immediately.
So imagine I'm searching through a list for a specific item. If I find it, I can use break to stop the loop right there, even if there are more items left to check.
Perfect example. It saves you from unnecessarily processing the rest of the list.
That's super efficient. Now what about continue?
Continue is a bit more subtle. Instead of ending the whole loop, it just skips the rest of the current iteration and jumps back to the beginning of the loop for the next one.
So it's like saying, okay, this particular item doesn't meet our criteria. Let's move on to the next one without doing anything else with this one.
Precisely. Imagine you're processing a list of numbers and only want to do something with positive values. You could use continue to skip over any negative numbers without affecting the overall flow of the loop.
I'm starting to see how these tools can make loops much smarter and more responsive to the data they're handling.
And they open up a world of possibilities for creating complex logic within your programs. You can have loops that react differently based on specific conditions, make decisions on the fly. It's all about combining these fundamental building blocks.
This is amazing. It feels like we're going way beyond just repeating the same actions over and over. We're building intelligence into our loops.
And you know what's interesting? As you work with larger Python projects, you'll start seeing how these loop concepts play a crucial role in organizing and structuring your code.
What do you mean? How do loops help with organization?
Well, remember how indentation in Python is crucial for defining blocks of code? That becomes even more important with loops, especially nested ones.
Right. Python uses indentation to figure out which lines of code belong to which loop or conditional statement. If we mess that up, the code won't run correctly.
Exactly. So as you start writing more complex programs with multiple loops and conditional statements, that careful indentation will become your best friend for keeping everything clear and readable.
It's like the visual structure of the code helps us understand the logic behind it.
And it's not just for you. That clear structure makes it much easier for others to read and understand your code as well, which is crucial for collaboration on larger projects.
Makes sense. Well, organized code is happy code. But now I'm curious, is there anything beyond indentation that helps manage complexity in larger Python programs?
Well, there's a whole world of tools and techniques, but one fundamental concept you'll encounter is functions. These are reusable blocks of code that you define once and then can call multiple times throughout your program.
So instead of writing the same code over and over, I can just put it in a function and then use that function whenever I need it. That sounds incredibly efficient.
You got it. And the best part is functions and loops work together beautifully. You can have loops inside functions, functions that call other functions containing loops. It's like building with Legos, creating increasingly complex structures from simpler pieces.
Now, that is a powerful image. It's like we're building our own little programming universe, one function and one loop at a time.
Exactly. And that universe can be used to solve real-world problems, automate tasks, create games, analyze data. The possibilities are endless.
So we've gone from simple loops to nested loops, learned how to control their flow with break and continue, and now we're talking about functions. I'm starting to feel like a real Python programmer.
And you should. You've grasped some of the most fundamental concepts that form the backbone of any Python program. But we're not done yet. Ready to see how all of this translates into real-world applications.
Bring it on. I'm eager to see how Python loops come to life in actual projects. Okay, so we've explored those inner workings of Python loops, from those basic for and while loops to nested loops and those flow control tools like break and continue. And now I'm really curious to see how all of this theoretical knowledge actually translates into real world applications. Like, what can we actually do with these powerful looping structures?
You can think of loops as the unsung heroes of programming. They're quietly powering so much of what we do with code, especially when it comes to tasks that involve repetition or handling sequences of data.
You're saying they're not just some neat coding trick. They're essential for solving real problems.
Absolutely. Take game development, for example. Think about how a character moves smoothly across the screen. That's likely a loop running behind the scenes, constantly updating the character's position based on player input or game logic.
So it's not like the program just tells the character to move from point A to point B once. It's more like a continuous process managed by a loop.
Right. The loop keeps checking for input, calculating that new position, and updating the character's location on the screen, creating that illusion of smooth movement.
And I bet those loops are also working hard to handle things like collision detection in games.
Exactly. Let's say you're playing a game where you collect coins or power-ups. A loop can constantly check if the player's character overlaps with the position of those items. And if it detects a collision, the loop triggers the code to update the player's score or inventory.
It's like loops are the multitasking wizards of the game development world.
And their powers extend far beyond just games. Think about data analysis. Imagine you have this massive spreadsheet with thousands of rows of customer data.
Oh, yeah, that sounds overwhelming. What could loops do to help in that situation?
Let's say you want to calculate the average age of your customers, or see how many of them live in a specific city. Instead of manually going through each row, you could use a loop to process the data automatically.
So the loop would go through each row, check the customer's age or location, and then store that information to calculate the average or count the occurrences.
Exactly. Loops are incredibly efficient for these kinds of repetitive tasks. Saves you hours of manual work. It's like having a super-powered assistant who can crunch numbers at lightning speed.
Yet data analysis is definitely one area where I can see the value of automating those repetitive tasks.
And it doesn't stop there. Loops are also essential in web development. Imagine you're building an online store with a product catalog. You wouldn't want to manually write the HTML code for each product, right?
Oh man, that sounds incredibly tedious. How could loops help with that?
Well, you can use loops to dynamically generate the HTML for each product, pulling information from a database or a list of product data.
So the loop would run through the product data, create the HTML elements for each product description, image, price, and so on, and then just put it all together in a nicely formatted web page.
That's it. It's a much more efficient and flexible approach than hard coding every single product. Loops allow you to create these dynamic websites that can adapt to changes in your product inventory or display different content based on user preferences.
It's amazing how these looping structures, which seemed so simple at first, can be used to build such complex and powerful applications.
It all comes down to understanding those fundamental concepts and then just applying them creatively to solve problems and build amazing things. And remember, we've only scratched the surface here. There's a whole world of advanced techniques and libraries in Python that build upon these basic looping principles.
That's what's so exciting about learning to code. There's always something new to discover and explore.
And as you continue your journey from Scratch to Python, I encourage you to keep that curiosity alive. Experiment. Play around with the code and see what you can create. You might be surprised by the incredible things you can accomplish with the power of loops at your fingertips.
That's fantastic advice.
Mm-hmm.
I'm feeling inspired to dive into some real Python projects now and see what I can build. Thanks for guiding us through this deep dive into the fascinating world of loops.
It's been a pleasure. And remember, the key to mastering any programming concept is practice and experimentation. So get out there, have fun, and keep on looping.